Let's see this question. This question is given in GATE 2012 in the subject analog. Okay, the circuit shown is a, okay, they have given a circuit. They are asking whether this is a low pass filter or high pass filter with gain f 3 dB. Okay, now first of all, if you observe there is nothing given about op amp. Okay, take the op amp is ideal, op amp ideal. Okay, now if an op amp is ideal, we know that voltage gain AV is equals to infinity. AV is nothing but V0 by VID is equals to infinity. So we can write VID is equals to 0. VID is nothing but the difference between two input terminals. Okay, the difference between non-inverting terminal and inverting terminal is 0. From this we can write V plus is equals to V minus. So this is called virtual short. Virtual short. Virtual short is a condition where the voltages at inverting terminal or non-inverting terminal are same, and for an ideal op amp, input impedance Ri is equals to infinity. By this, no current flows through op amp. Okay, so current flow is equal to 0. Current flow will not take place. Okay, if you observe here, this is the current I1, this is the current I1, and this is the current I2. Since no current flows through op amp, I1 is equals to I2 because all the current flows through in here only, in this direction only. So I1 is equals to I2. From this we can write here I1 is equals to I2. From this it Vin minus 0 by R1 plus 1 by SC is equals to 0 minus V0 by resistance is R2. Okay, simplify such that it will be V0 by Vin. Now cross multiply Vin into R2 equal to minus V0 into R1 plus 1 by SC. Now take V0 by Vout. V0 by Vin equal to, okay, V0 and Vout both are same. V0 by Vin equal to V0 by Vin equal to R2 by minus will be there, R1 plus 1 by SC. Now take R2 by R1, R2 by R1 common, and it will be 1 by 1 plus, it will be 1 by SC R1. Okay, now we know that S equal to J omega, substitute there, minus R2 by R1 into 1 plus 1 by J omega C R1. This we can written as minus R2 by R1 by 1 plus J into F1 by F, where F1 equal to 1 by 2 pi R1 into C. This is in terms of hertz. If we want radians per second, this will be 1 by R1 into C in terms of radians per second. Okay, this is F1 or F3 dB or cutoff frequency. By looking into this gain, we can say that this is a high pass filter. High pass filter with gain equal to 1 by R1 into C. In the options, option B is the correct answer. Option B is the correct answer, but we will verify whether this is correct or not. For high pass filter, the graph will be like this. There will be a point called cutoff frequency. Okay, cutoff frequency F1. Now after the cutoff frequency only, it will allow all frequencies to pass through it, and this is called pass band. Before this cutoff frequency, no frequency is allowed here. Okay, this is called stop band. For all frequencies, F1 will be less than F. For here, F will be less than F1. Okay, this is the graph for high pass filter. Now we calculate the gain. V0 by Vin mod is equals to minus R2 by R1 into 1 by 1 plus J F1 by F whole square under root. Now here it is two cases. In case 1, assume that F1 is less than F. okay. F1, the numerator in here will be less than F, so this will become 0, and V0 by V in is equals to minus R2 by R1 divided by 1 itself, okay. This is for F1 is less than F, so it is allowing all frequencies when F1 is less than F. Now case 2, when F is less than F1, in this F the denominator will be less than F1, so this will become 1 plus whole square, so this will become V0 by V in 1 by 2 large, because here F is smaller compared to F1, this part is smaller, so denominator will be larger, whole square of denominator will be much more larger, so 1 by very large, it implies small, and we can even simplify to 0 also, okay. So gain equal to 0 whenever F is less than F1, so at this part gain is 0, and this part it is having some gain minus R2 by R1, so this is a high pass filter with F3 dB frequency as 1 by R1 into C.